This graphene liquid cell enables in situ transmission electron microscopy for lithium dynamics in a liquid electrolyte.
Such dynamics can provide rich information of the working mechanism of lithium-ion batteries and contributes to designing advanced battery devices.
The advantages of graphene liquid cell is that it allows TM imaging in liquid electrolyte, providing good spatial resolution and high imaging contrast.
In addition to a superior quality of the image, it can also provide information on various morphological, phase, and interfacial transitions.
With only a written protocol, it is difficult to follow this method because many technical steps are conducted by hand.
A lot of these skills require accuracy and precision, where the use of pinset is highly recommended. Even though you follow every protocol correctly, you can still fail the experiment because handling graphene and the graphene transfer grids is difficult.
To begin, prepare the electrospinning solution as described in the accompanying text protocol. Transfer it into a 10 milliliter syringe and equip the syringe with a 25 gauge needle. Then, wash the target. Take a rectangular piece of flexible stainless steel and wash it with deionized water followed by ethanol. Repeat this process 2 to 5 times. Once clean, air dry the steel at 60 degrees Celsius for 10 minutes. Once dry, fix the flexible stainless steel onto the drummer with tape. Next, open the electrospinning controller software and enter a flow rate of 10 microliters per minute, requiring a total solution volume of 5 milliliters.